All right. So today we're going to be talking about words, equations, tables, and graphs. It's basically 4 ways to represent functions. So we're going to use multiple representations to represent functions, and we're going to translate among different verbal, tabular, graphical, and algebraic expressions of functions. Oops. So let's get started. So a function is a relation in which each member of the domain is paired with exactly one member in the range. A function rule is the operation performed or operations performed on the domain value to get the range value. A function table is a table that lists the x-coordinates, the input, rule, and y-coordinates, or the output. Okay? So basically what a function is, it's a machine, okay? It has a little spout for input, and that is all of your x values. And then you have a little spout, and what comes out is your y values. And what's inside there is the rule. So every time I plug an x in, it runs it through the rule, and it spits out a y, okay, or an output. That is a function, okay? So let's look at a problem. It says June is ordering tickets for a show. Tickets cost $22 each, and there is a $6 surcharge per order. Make a function table for 4 different input values and write an algebraic expression for the rule. Then state the domain and range of the function, okay? So in this problem, it told us to do 4 different inputs. So we do whatever inputs we want to do, okay? So the first thing that we do in step 1 is we should create a function table showing the input, rule, and output, and then enter 4 different input values. So input 1, output, and then the rule, okay? So set up 3-column table. I can choose 4 different ones. So I'm going to choose in this case, 1, 2, 3, and 4. Okay? So then I take my input, I put it into the rule. 22 times 1 plus 6 gives me my output of 28. I do that for number 2. 22 times 2 plus 6 gives me 50. Number 3, 22 times 3 plus 6 is 72. Number 4, 22 times 4 plus 6 is 94. So now I have my table done because I did 4 different inputs, which is what it told me to do. Now I would list my domain because it says state the domain and range of the function. So my domain is all of my x values, and my range is all of my y values. Now I've answered the entire question. Okay? So that's how you would answer one of those. I'd make a table, solve it, and then do my domain and range. All right. So pause the video, work on this one on your own, and come back and see how you did. All right, let's see how you did. So Jenna picked a game card with the function shown. Make a function table for 4 different input values and write an algebraic expression for the rule. Then state the domain and range of the function. So here's the rule. It says triple the number and subtract 1. So let's look at the rule. Triple, that's 3 times the number, and then subtract 1. So that would be my rule, okay? Then it tells me 4 different values. So I could simply just do 1, 2, 3, 4. And then I plug those in. 3 times 1 minus 1. 3 times 2 minus 1. 3 times 3 minus 1. And 3 times 4 minus 1. Again, I could have used any numbers I wanted to for my x. Then for my y, that would be 3 times 1 is 3 minus 1, so that would be 2. 3 times 2 is 6, minus 1 would be 5. 3 times 3 is 9, minus 1, which would be 8. And 3 times 4 is 12 minus 1, which would be 11. Okay? Yeah. So that's my y's. Then I would list out, it says state the domain and range. So I would just say domain, and that would be my x values. 1, 2, 3, 4. Then I would do my range, and that would be my y values. 2, 5, 8, and 11. Okay? So now I have answered the entire problem, everything it asked me to do. I created the table, I wrote an algebraic expression for the rule, and I stated the domain and the range. Okay? All right, I'm sure you all did wonderful. So let's take a look. We can represent a function in several different ways. So words, equation, tables, and graphs can be used to represent a function. An equation is a mathematical sentence stating that two quantities are equal. So we've been using what's called an expression. An expression does not have an equal sign. An equation does have an equal sign. So functions are often written as equations with two variables, one to represent the input, or the x, and one to represent the output, or the y. All right. So we have here 4 different ways to represent the same data. We have words. Distance is equal to 60 miles per hour times the number of hours. We could show that in equation. D equals 60 times t, okay? Or distance equals 60 miles per hour, and t would be number of hours. All right, we could list that in a table. So we have the number of hours under time, and then we have the distance, okay? So in 1 hour, it'd be 60 miles. 2 hours, be 120 miles, so forth. Then we can also represent that same function in a graph. So we could take those x, y's that we found, and we could plot them into coordinates. So for example, 160 would be my x, y, the first one, and it would be at 160 would be my first dot, okay, or my first coordinate. So I could represent that function in all those 4 different ways. So this first problem says, Tori's computer backs up the file she is working on every 5 minutes. Make a function table to find the time for 3, 6, 9, and 12 backups. Then graph the ordered pairs. So the first thing I want to do is state what the variable represents. So in this case, we're going to let M represents the number of minutes and B represents the number of backups. So my rule would be, well, I just wrote right through that rule. So my rule would be M equals 5B, or the number of minutes equals 5 times the number of backups, okay? Then I can plug what they tell me my x's are, or my inputs, at 3, 6, 9, 12. I plug them into the rule of 5 times b, so 5 times 3, 5 times 6, 5 times 9, 5 times 12. I solve that, and that gives me my y's, or my outputs, okay? So now my table's done. The next thing it says to do is then graph the ordered pairs. So this ordered pair would be 3, 15. This ordered pair would be 6, 30. This ordered pair would be 9, 45. This ordered pair would be 12, 60. Okay? So I make me a coordinate plane. Don't forget my y's are on this side. My x's are on this side. Okay? Because my inputs are at the bottom, x's, and my outputs are the y's, or on the left side. Okay? And then I can number them however I want to number them. In this case, since I know I'm going 3, 6, 9, 12, I could just go by 3's at the bottom. And then I know I'm going from at least 15 all the way up to at least 60, so I could go by 10's, okay? And then I just simply plot 3, 15, 6, 30, 9, 45, and 12, 60. Now I've represented this in every way that it tells me to, so I've finished with the problem. I'm done. I can move on. Okay? All right. So now's when you're going to pause the video, try this last one, and see how you do. And come back and check your answers. All right. How'd you do? Let's see. Victor's heart beats 72 times a minute. So A says write an equation to find the number of times Victor's heart beats in any number of minutes. So I could say, for example, H is going to equal heartbeats. And I can say M is going to equal minutes. Okay? Now I can write my rule. It says Victor heartbeats 72 times a minute. So I could say H equals 72 times M. Okay? So then it says to make a function table to find the number of times Victor's heart beats in 5, 10, 15, and 20 minutes. So I can make a table like this one down here. I can put my rule in here. H equals 72M. Then I know they give me my inputs. So 5, 10, 15, 20. I then apply that to the rule. So 72 times 5, 72 times 10, 72 times 15, and 72 times 20. Okay? Then I can get my output. So 72 times 5 is going to give me 360. Then 72 times 10 would be 720. 72 times 15 would be 1080. And 72 times 20 would be 1440. Okay? So now I solve B. Now C says graph the ordered pairs of the function. So again, my heartbeats is going to be on my Y and minutes would be on my X. And then I simply solve. 5, 360. So 360 would be about right here. 10, 720 would be approximately right here. And then 15, 1080 would be approximately right here. And on 20, 1440 would be about here. So now I finished my graphing. So now I have answered everything that problem's asked me to answer. A, B, and C. Okay? All right. If you have any questions, let me know. Otherwise, go ahead and continue on to your homework.